Hello, in this screencast we're going to discuss how to write a conclusion so that you can get it right every single time and score really big on it. This is something that you are going to be able to use not only in biology class or chemistry class or AP Environmental Science, but in all of your other classes. And this is just the foundation of what you need to build off of when you're writing a conclusion. And for each of your different classes, there would be different features or characteristics that you would just tweak or change. But here's the basics. Let's start with the first thing. The first thing that you want to do is you want to rephrase your hypothesis. So first you have to look at your data, analyze your data, and decide if that data supports your hypothesis or refutes your hypothesis. If you're not familiar with the word refute, it means to be proven wrong. So once you decide what your results tell you, then the next thing that you have to do is rephrase your hypothesis to express that support or that lack of support. And in rephrasing, that means you're taking your hypothesis out of the if-then statement. Because an if-then statement, if you remember, is your cause and effect. And your cause is really your manipulated variable, and your effect is your responding variable. And that's testable. And we've already done our test. So we want to take it out of that testable question and put it into a statement that says that the effect was the result of the cause or the effect was not the result of the cause. So let's look at an example. Let's say we have the hypothesis that says if an enzyme is chilled, then it will slow the function of enzyme activity. So our cause is if the enzyme is chilled, that's what we're manipulating, and the result, the responding, is that this enzyme activity will slow. So let's say that my hypothesis was supported. So I'm going to rephrase that to express that support by saying enzyme activity will slow when the enzyme is chilled. So I'm telling you, yes, in fact, that's true. It does slow when it's chilled. Okay, so that's what you're going to need to do. You're going to change that if-then statement to a statement that expresses support or refutes it. I can flip this around and let's say this isn't what happened, and we could say enzyme activity will not slow when the enzyme is chilled, or enzyme activity speeds up when the enzyme is chilled. So I can take that and I can apply whatever I learned from my data to express my support or whether I'm refuting that statement. I hope that makes sense. So let's take a look at the next step. And of course, we're all going to do this in paragraph form. And the next thing after we have that rephrased hypothesis, we want to add some background information that would support that. Something that we already know, something that we collected, some information that we collected prior to this. So here's our example. Enzymes are catalysts of living things and regulated by other enzymes, pH, and temperature. Enzymes that help to fight disease often work better when the body temperature is above 98.6 degrees Fahrenheit. So that's some information about enzymes. And that's background information. That's not something that I have obtained from performing the experiment, but that I got from research that I did. So I give some information about enzymes. And I tell you that temperature and pH and other enzymes can have an effect on that, and that it can work better when the temperature is above 98.6 when enzymes are used to help fight disease. So that's something that I added as background support. So the next thing I'm going to do now is I'm going to look at that data and I'm going to see what data is a concrete example of what I just said. And if I want to make this good, I want to use a combination of qualitative data, something that is going to describe what happened, and quantitative data, which are numbers that I can use for comparison. And sometimes not always both are available, but you want to use both when they are available. So here's an example. When the temperature of the enzyme was raised to 105 degrees Fahrenheit and added to the chicken livers, the reaction fizzed, lasting for 30 seconds. In contrast, when the enzyme was cooled to 50 degrees Fahrenheit, the reaction fizzed as before, but it slowed, lasting 60 seconds. So I told you it fizzed, there's my qualitative, and I gave you a comparison of my quantitative from 30 seconds to 60 seconds. So 30 seconds is a quicker reaction, 60 seconds is a slower reaction for that. The next thing that you're going to do is account for any errors. And with everything that we do, there's always going to be a margin of error somewhere. The accuracy of the equipment that you're using, the skill of the experimenter, the chemicals or the items that we're using might become perishable after a certain time and might have already been a couple of days old. So we need to consider those errors because they can have an effect on the data that we collect, and they could have effect on making our conclusion reliable. So we need to account for that. So if I use the example of the enzymes, maybe I used my cell phone to record the time, how long the reaction lasted. So I could say the cell phone was used to time the rate of the reaction of the enzymes. By the time the button was pushed on the phone, it could have altered the rate of the reaction from 2 to 3 seconds. So I'm kind of telling you that there could be a little bit of uncertainty with my timing because of my reaction to turn the phone on and off during the timing. There's some times where errors might not be as obvious, so you need to listen to other results that people are getting and just kind of doing a mental comparison to see if your results are falling within the same range as theirs. And then that way it'll help you decide if there was an error or not. Then the last thing that you need to do is make a closing statement or a summation. You have to be able to draw everything together in a closing statement. It's going to repeat again whether the hypothesis was supported, and it pulls your findings together. So with the same example that we were using, temperature does affect the rate of enzyme activity. Warm temperatures within a livable range speed the reaction, while cold temperatures within a livable range slows the rate of the reaction down. Okay, so we brought it to a closing statement. So those are the 5 main parts of a conclusion. That information that you put in could be just a couple sentences in length, making it maybe just a paragraph, or depending on the material that we're doing or the experiment that you're doing, could be 2, 3, 4 paragraphs in length, depending on the data that you collected. Some additional things that you need to know. You need to keep in mind that you are writing a scientific paper. So this is a form of formal writing and should be written that way. You need to avoid bias. You don't want to put your feelings in. You don't want to say, that I like this experiment or I didn't like this experiment. Keep that out, so make sure that you're not putting any sort of bias in. You're never to use any personal pronouns such as we, us, ours, me, I, you, yours. They do not belong in any part of the lab. The word they is the only acceptable personal pronoun that you can use, because there will be times you will watch living organisms and you have to tell how they will interact. So they is acceptable. You never want to use phrasing that includes the word prove or proven or proved. So you wouldn't want to say the hypothesis was proven or I proved, because there you're doing two things. You're putting a personal pronoun in. And the same thing with conclude. You don't want to say anything that has the word conclude or conclusion in it. I can conclude, or it can be concluded, the conclusion, or in conclusion. Okay, so stay away from that. You also don't want to say my hypothesis or the hypothesis. You want to rephrase it. You want to take it out of that hypothesis. And also do not have if-then statements in the conclusion, because if-then suggests that you're testing and you've already tested. You're analyzing your results and you're making your conclusion based on those results. And one thing that I left off here is when you're rephrasing that hypothesis, do not start that rephrased sentence with when. When is the same as if. So stay away from that. So I hope this is helpful in helping you to write a conclusion. If you have any questions, as you know, please ask me. All right, bye.